All right. So this lesson is about the sexual response cycle. So the first couple slides here are just about um, hormones. Just a quick review from the last PowerPoint that we went over. So sex hormones, sexual behavior. Some lower animals are almost completely governed by their sex hormones. And there are two basic effects that you can think about when talking about these. There's organizing effects and activating effects. Organizing effects are uh, what predispose you to being either masculine or feminine in how you act, and activating effects are what drive the sex response itself. So you should already be familiar that ovaries produce estrogen and progesterone. Estrogen, we talked about as like the egg-setting hormone last time. Just a generic term that kind of leads to those secondary female sex characteristics we talked a little bit about, and helps regulate the menstrual cycle. Progesterone, um, it's going to promote the growth of sex organs, maintains pregnancy, and helps regulate the menstrual cycle as well. And then menstruation, which probably some of you are familiar with, is that monthly shedding of the uterine lining, also been known as like a weeping uterus, because it's sad that you didn't end up pregnant and it doesn't get to use the building up that it was doing. But it's going to reset everything, and they kind of said it's like tearing down the drapes and you kind of discard them. So that's when you bleed once a month if you're female. So testosterone in adulthood activates masculine behavior patterns, and it's kind of a competition between estrogen and testosterone. I believe it was The Longest Yard. It was a pretty funny scene where they slip one of the big football guys like estrogen pills, and he thinks he's taking his roids, and then he becomes very female in his characteristics. He starts like crying and giving his teammates a shoulder to cry on, and they're just like, "Dude, what's up with that? Like, why are you doing that?" Um, but it's all just a balance between estrogen and testosterone. So testosterone activates more masculine patterns. So females can have more testosterone and act more masculine. I'm sure guys have met females who act more masculine than they think they are, or vice versa, guys that act more feminine. So it's just a balance. Men who are castrated or given drugs that decrease testosterone eventually show a lack of sexual desire. Testosterone stokes that desire in men and women to have sex. Ultimately, it's not really on the slide, but the point of sex is to share DNA, and then you would get better traits for your offspring to survive. So this PowerPoint lecture, there's nobody up here in my garage with me, kind of takes away some of the awkwardness of delivering this in a classroom. But here's an embarrassing picture. Sexual behavior and response. So I got a lot of statistics. These came from 2016, 2015, most of these. Haven't updated it for a couple of years now, but they really don't change that much. So it's talking about risky sexual behaviors that teenagers take. And I might be getting off the track a little bit with this as to exactly what our scope and sequence says you guys should be learning. But I feel like it's pretty relevant for the sexual response cycle and a good reminder from your health class. So out of U.S. high school students surveyed in 2015, 41% had had sexual intercourse. 30% had had it in the previous 3 months. And of those, almost half did not use a condom. 14% took a risk and didn't try to prevent pregnancy at all. And 21% had drunk alcohol or used drugs during or before around that time. Only 10% of all students have been tested for HIV. And the CDC data also shows that lesbian, gay, bisexual high school students are at substantially higher risk for these health outcomes. There's usually so many great questions in class, but I don't get that opportunity now to answer them. Sexual risk behaviors place youth at risk for HIV and STDs. Young people accounted for 21% of all new HIV diagnoses in the U.S., so 1 in 5 in 2016. That's very, very high. Out of those, 81% were gay and bisexual males. Half of the 20 million new STDs reported each year were among young people between 15 and 24. And about a fifth of a million babies were born to girls aged 15 to 19 years. That is a young age to have a baby. Alright, so here's where we actually get into the standard here that was about the sexual response cycle. So the sexual response cycle is characterized by vasocongestion and myotonia. Myotonia, so that's muscle tension, muscle tone. So we got these two definitions here. Let me get out my little marker. So these are very important definitions. You should be following along in your OneNote notebooks. So vasocongestion and myotonia. So myo, we remember from Unit 3, muscles, means muscle. Tonia is pretty self-explanatory, I feel like. It's tone, so muscle tone. So this comes out to be muscle tension. Vasocongestion, so this is like vessel, and the vessels are very congested, meaning they're full. Like congestion on a highway, right? So vasocongestion is congested blood vessels. So things start to swell and fill up with blood. So engorgement of blood vessels with blood swells the genitals, breasts, during sexual arousal. So there's excitement, plateau, orgasm, and resolution are the 4 phases, and we're going to have a slide for those. So here's the excitement phase, and there will definitely be some awkward quiz questions that ask you which phase like couples are in, because that's what the standard wants. So the excitement phase is the first phase of sexual response cycle, which is characterized by erection in the male, vaginal lubrication in the female, myotonia, there's that word again, muscle tension, and increases in heart rate in both males and females. So, you see them in the movies, and they're like, oh, and their heart flutters because they're in the excitement phase, technically, of the sexual response cycle, which is, we're using science to explain all this. So in the excitement phase, men experience an erection, the scrotal skin thickens, and the testes become enlarged. In women, the vagina becomes lubricated, the clitoris swells and flattens, the breasts enlarge, and the vessels near the surface become more pronounced. So plateau phase is the second phase of this cycle. It's characterized by more vasocongestion, so even more blood in the area, more muscle tension, higher heart rate, and blood pressure in preparation for the orgasm. So in the plateau phase, breathing becomes very rapid, almost like panting. Heart rate increases to 100 to 160 beats per minute, so it's like an aerobic exercise. And in men, the head of the penis shows some size increase, and in women, the outer part of the vagina swells, contracting the vaginal opening. And students always, balk at this word for grasping the penis. So the third phase in the sexual response cycle is the orgasmic phase. So characterized by pelvic contractions and accompanied by intense pleasure. So if we go back to the nervous system, I think we mentioned the fight or flight and rest and digest systems. And there was a couple questions in there. It was kind of around midterm exam time. There were a few questions in there about, what happens during an orgasm. And it is very, very controlled by the mind. So what happens really is you're trying to relax this whole time. And we'll get into this a little bit at the end. But as you're relaxing, you're in parasympathetic, right? You shouldn't be in fight or flight when you're going through these phases of the sexual response cycle. And in fact, you're going to have trouble getting an erection and going through these phases if you're in fight or flight. It's just not made for that. So the orgasm phase is characterized by a rapid switch from parasympathetic to sympathetic. So you go from rest and digest to fight or flight in that instant, and that short circuit of the rest and digest and sympathetic nervous systems is what actually causes the pleasurable feeling and all the endorphin release and the orgasm. So manifested by lots of pelvic contractions and tightening of the muscles surrounding the vaginal barrel. That's another one. Thinking of the vagina as a barrel always, got students saying, well, why do they word it like this? Trying to be as scientific and proper as possible. In the male, the semen collects at the base of the penis and muscle contractions propel the ejaculate out of the body. And then there's the fourth phase called the resolution phase. So the resolution phase of the sexual response cycle is when we return to the pre-aroused state. So men have a refractory period in which men cannot have another trip through the sexual response cycle. And it's for about 15 to 20 minutes. That's pretty much it. Women, however, can have multiple. So this graph is always a fun one to explain here. So here's men. You know, time is on our bottom axis. So as we move through time, we're going up and down through these phases. So here is excitement. We get all of the engorgement of blood, the muscle tension, plateau, and then the orgasm phase, and then resolution. So if you notice, men don't get this like refractory period. We just fall back down to fall out of the sexual response cycle. Females, however, and everyone always wants to know why there's an A, a B, and a C. Well, women are very different with how they experience orgasms. So you can have A, which I think would be the kind of typical. So they're going through the excitement phase, and this graph almost looks like they're in excitement all the time. They plateau, and they can experience multiple orgasms over time, and then when things are done, they go back down and out of the sexual response cycle. There's a B, which kind of gets here and never really goes over the top, but you know, they're having a good time, I guess, in the plateau phase. And then there's C, which is all this disjointed and broken, and you know, they reach a higher high than everybody else, but they got there, and sometimes it was great, sometimes it wasn't. I don't know. So that's a very interesting chart that I like to share. And then, so the top score number 4 out of 4 for this. Remember, we're always trying to get to score 3, which is just to understand the sexual response cycle for this lesson. But score 4 in anatomy is almost always about diseases and disorders. So I usually like to talk a little bit about sexual dysfunction in this lesson. There's usually so many great questions about this stuff, and you know, this virtual teaching is tough. So types of sexual dysfunctions. So persistent, recurring problems in becoming sexually aroused or reaching orgasm. And I've hinted at them a little bit. You could just literally have a low sexual desire, and that might tie back into things like testosterone being too low. Remember, that activated the sexual response. There's one called female sexual arousal disorder, difficulty in becoming sexually aroused, so the vagina might not be lubricated, and it can come from all kinds of things. You know, if you're worried, there's a thing called performance anxiety. So what happens is, one time you have a problem with going through this cycle, and then the next time you're like, oh no, I hope I don't have the same problem. Well, if you're worried, right, you're not going to be in the parasympathetic rest and digest. You're going to be in fight or flight. So if you can't relax your mind and let this cycle take its path and its course the natural way, you're obviously going to have some problems with like arousal disorder. I have more slides. I don't want to go off course here. So male erectile disorder. I can take this back to nutrition a little bit. Oftentimes, I always mention in class low T. So low T, the T means testosterone, obviously. Men, typically when they get into their 50s, 60s plus, they've been abusing their body with diets for so long that they have a condition called low T as a comorbidity with a bunch of the other stuff that they've done to their body over time. So if you eat poorly your whole life, you know, you end up with cardiovascular disease. Eventually, you're going to have trouble getting and maintaining an erection. And often that's related to low testosterone, because fat, which, you know, a lot of Americans end up with a little extra body weight, that fat actually kind of stores and helps create estrogen. And remember, it's a balance. So if you got too much estrogen, you don't have a lot of testosterone relatively, which means you're going to act more feminine. So if you don't have a lot of testosterone, you're not going to be able to get and maintain an erection. So you end up with male erectile disorder. And you know, you've seen the ads probably for Viagra and Cialis, and they try to solve this problem with drugs. Really, take care of yourself, and you probably won't ever have the trouble. Orgasmic disorder is when you have trouble reaching an orgasm, even though you've received sufficient sexual arousal. Premature ejaculation is just happens too soon, or with minimal sexual stimulus. So the causes, and I hinted at this earlier, could just be you're tired. Could be diabetes, a comorbidity. It could be certain drugs you're taking, illegal or non-illegal. Illegal or legal, could be prescription drugs is what I mean. And then they can all impair sexual performance. Female sexual arousal is psychological, so that's what we were talking about, rest and digest. And you can go and do these things called sex therapy. It's not what the teenage boys in the room might be thinking it is. It's literally someone talking you through the problems and what might be related to your performance anxiety, right? Did you have a time when something bad happened and you're thinking about that all the time? And this can go back to a lot of different root causes. So they're going to work with you to change those self-defeating attitudes. They're going to teach you new sexual skills. They're going to enhance your sexual knowledge and improve your sexual communication so that you can enjoy this sexual response the way it was supposed to be. All right, one more thing that I lumped in here. We're going to talk about spermatogenesis and oogenesis, which is the creation of sperm and eggs. So we're going to talk a little bit about biology stuff that you probably reviewed before. How much time on that? 16 minutes, not bad. So it occurs in the seminiferous tubules of the testes. We've definitely talked about that, I think, last unit. Oh, it's hard to see my cursor on here. So spermatogenesis is another one of those words you can break down, right? Sperm is very obvious, and genesis, most students tell me, is like creation of. So this is creation of sperm, aka formation of sperm. It takes 65 to 70 days. Starts with one cell called a primary oocyte, and very importantly to note, these replicate with mitosis. What did the brother cell say to the sister cell when she stepped on his toe? Ouch, mitosis. My daughter told me that one. Anyway, so because this is mitosis, it's a perfect copy of itself. So we're making new primary spermatocytes by cloning. So we've got 46 or 23 chromosome pairs, 46 chromosomes in all of those cells. Now, when one of those is selected to become sperm, it splits the 46 into two 23 pairs, and then the 23 pairs separate. So now we've just got 23, 23, 23, and 23. So we go from what's known as diploid, meaning we've got two copies of the 23, to being haploid. We've got one copy of 23 in each sperm. So this picture pretty much explains it all here. We've got two copies of our 23. So here's our diploid primary spermatocyte. Getting ready to split via meiosis now, right? Meiosis is when we have the number of chromosomes. So we're going from copies, splitting up here, and then those copies we get rid of the backup redundancy, the pairs. We split the pairs, and then they grow, tails, and this very specific, amazing little racing sperm. So just a reminder here, another picture. So we got diploid, and those reproduce via mitosis to themselves to create extra of those, and then every once in a while they go and they split into haploid cells, and then those haploids split into 4 sperm cells. So true or false? A woman is born with all the eggs she'll ever have. Last class we said true. Now that's technically not true, and they go in this slide. This came from a psychology book, I think. They'll become eggs later. Right now they're called primary oocytes, so they could become eggs. And that's where the technically not true is coming in. They're not eggs yet. Do you have the cell that will eventually contain your son or daughter in your body? Yeah. It's just not been selected to become mature yet. And they go on to talk about how a bunch of these are going to die. So let's see. When they're at 16 to 20 weeks of pregnancy, 6 to 7 million oocytes. But then most of them die before you're even born. You're only got 1 to 2 million left. And then at puberty, remember we definitely talked about this in the last lesson. At puberty you've only got 300,000 left. So they've been going through your whole life with you and enduring all your bad or good decisions. And that's why having late-term pregnancies is really not a great thing to do, because if you're going to get pregnant at 45, you've had those eggs for 45 years now. And they've been through a lot. There's not that many left. So that's why the risks for Down syndrome and other things are higher when you're having an older, high-risk pregnancy. All right, oogenesis. So on to the females. So we begin with the one cell, which becomes 2, and then finally 4, just like sperm. However, and this is probably why they had that technically not true, right? So here's the cell that will eventually become your son or daughter, right, that I said you were born with in the last one. It's really hard to make a star with a pad. It splits the meiosis into the secondary oocytes, into this thing here, and what's called the first polar body. So if you'll notice already, we're not making identical copies here. One of these got selected to become the actual egg, one of them did not. So we've gone from 46 chromosomes, 23 pairs, and we've split them up into just 23 chromosomes. Okay? And now these chromosomes are going to split and get rid of the backup data, right? So they're going to split one more time via meiosis 2. Ooh, and it's actually stimulated by the sperm cell. I learned something from this picture. Probably shouldn't admit to that on video. No way I can delete this. Oh well. Enjoy this if you're listening. All right, so this one splits now. The second polar body here. Also, these just get cast away and they shrivel up and they get reabsorbed by the body. And this one here, that's technically only 1/4 of the original, our little star up here, right? Because we had 23 pairs, and this has only got 23 chromosomes, no pairing or anything else like that. This is what is actually an egg. So here we go. All this is beginning prior to birth, and it spans all your pre-reproductive and reproductive life. So the secondary oocyte is released by ovulation. So this is what explodes like a pimple out of your ovary. And then if you remember, we talked about the fallopian tubes. They got these fimbriae, these fingers that sweep it from basically in your intestines to sweeping it down into the fallopian tube, where it hopes it will meet an egg and become a baby and carry on the human species. So this ovulation of the secondary oocyte happens every 28 days. I think an average is about 26 to 35, and there are women who go outside of that. So here we got to review this cycle a little bit, and I know this is crazy. I definitely did not understand this whole cycle, and maybe it was because it didn't happen to me personally, but there's a lot of information in this cycle. So here we have pituitary hormones, luteinizing hormone and follicle stimulating hormone, and it's influencing that oogenesis to happen. So here's the little primary oocyte, and it's developing, and here it squirts out like a pimple, and then it hopes to get absorbed, to absorb a sperm and become a little human. And here's estrogen and progesterone, going up and down the roller coaster, and changing the uterine lining, and when the eggs are released. And this bottom one here is an actual picture of the uterine lining. So here, around day 4 or so, it starts to build up the uterine lining again in preparation for receiving that fertilized egg. And fertilization actually happens right about here, around day 14. And so that egg is released, and it has about a max of 72 hours to get fertilized by sperm. And remember, we talked about sperm being capable of hanging out here for up to 7 days, depending on if they're like super sperm. 3 to 4 days is probably more average, depends on the environment in the vagina at the time. So there's really just this small window of time when a girl could really, truly get pregnant, although there's lots of different things that can make it look like you're in this time when you're not. A period is not the only reason that a girl might bleed, so that could throw you off. Diet could throw you off 1 week. So that's why the calendar method or the rhythm method is rather ineffective. It works, it's about 80% effective, I believe, which is really not that good. That means 1 out of 5 months you would get pregnant on the calendar method. So the blood side here, if it doesn't get a fertilized egg, it weeps and it sheds the lining, and that is your period. So you have a little heavier flow here as things come out, and then it restarts the cycle all over again. Now, if you're a super ultra athlete, marathon runner, a lot of these, we mentioned fat in older men, that kind of like stores estrogen and helps like create a little bit of it. So if you are super ultra athlete woman and you have a very, very low body fat percentage, it's very common for you to like skip cycles. You might still be ovulating, even though you might not be bleeding every month. And that's why we said the calendar method is really unreliable. Even there, if you're pregnant, there's this interesting thing, and I don't have any slides about this, but there's this thing called lactational amenorrhea. So lactation is breastfeeding, and amenorrhea means lack of a cycle. Now the catch is, it's kind of this natural baby spacing. So if you're breastfeeding, the idea is you shouldn't be able to get pregnant because the baby feeding will release hormones that will suppress and stop this ovulation from happening. So you get no ovulation if the baby's feeding, which means there's no egg to fertilize and you can't get pregnant. So that would naturally, if you did it, it would, full time, which is a lot of work. If you did it full time, you wouldn't have a baby for about a year to 2 years. So you'd have this kind of natural baby spacing happening. The catch is, the first time that you ovulate, you will not bleed. So you're going to have this period of like a year to 2 years where you have no idea when the first time you're going to ovulate is. So if you're using this method to prevent a pregnancy, then it's a very good chance you'll miss that first ovulation and you'll become pregnant. So if you're not breastfeeding, that ovulation happens fairly quickly after birth. So you can actually get pregnant within a month or so after birth, depending on the hormone fluctuations that are happening here. And there's a lot of hormone fluctuation after pregnancy. I believe that's what our next slides are about. Basically, estrogen and progesterone just stay elevated throughout the whole pregnancy. That's why you are always very kind to pregnant women. And then when they deliver the baby, they all tank. They go like straight down. And that can be postpartum depression. It's kind of a preview of the next lesson, I believe. So I'll stop talking about it. All right, I believe we're almost done here. Or not, 24 or 45. I'm sorry, guys, 26 minutes. Not too bad so far. I'm going to make this a 2-week lesson. So, question, what cell division process is used in spermatogenesis and oogenesis? How do they differ? So they both use meiosis. Spermatogenesis needs many, many parent cells, and those parent cells, remember, are done by mitosis. So mitosis makes a perfect copy with all 23 pairs copied. And then meiosis is going to make it's going to have the number of chromosomes each time. All right, puberty. No air conditioner in the garage yet. Working on it. So puberty, I believe we talked a little bit about last class, but I'm going to try to frame it in this sexual response cycle hormone kind of picture that we're trying to hit here. So puberty is this period of rapid physical growth and sexual maturation. The sequence of physical changes is universal. The timing varies, and I believe you guys are familiar with most of this. Age of onset is between 8 and 15 years. So here we've got girls, about 9 years old. They increase the production of estrogen and progesterone. The uterus and vagina begin to grow larger around 9.5. Boys, finally, they catch up about a half a year later. They start increasing testosterone levels. Breasts will bud around age 10. Boys, the testes and scrotum begin to grow larger because, right, if you're going to be making testosterone, you need to increase the size of the factory, which would be the testes. 11, pubic hair begins to appear in girls. Boys, again, are about a half year behind. Girls have their peak height spurt at about 11.5. 12, girls have peak muscle and organ growth. This is about the time when your little brother, when he hits 12, he's going to finally be able to like beat you in a run, and you'll be disappointed because he'll reach that peak muscle and organ growth a little bit after you. Around 12, penis growth begins for boys, and menarche is something that at least the girls are familiar with. That's the first menstrual period. Average is about 12.5, but again, with our eating of certain kinds of meats and stuff in the U.S., for some reason this is getting pushed earlier and earlier and earlier. Some girls as young as 9, which would be a terribly hard age to explain what was going on to a little girl. So menarche is that first period, and a lot of people don't understand that around that same age there's also a spermarche, which is the first ejaculation. And also boys will put on a little spurt. And they love that word spurt. Another one that students always comment on. So 13, girls will have their first ovulation. Boys are hitting their peak height spurt. 14, girls' voice lowers, and boys are optimum physical conditioning. 15, final pubic hair patterns, boys' voices lowering. 16, you got full breast growth, and 18, boys get their final pubic hair pattern. So, so most of you in our class would be in this like 15, 16, 18 area. All right, so puberty begins. Typically, they define this as menarche and spermarchy, but we just saw from that chart it really starts long before that. So menarche is that first period, and it might be irregular at start. Spermarchy is that first ejaculation, which is going to be so hormones influence mood and thought. Oh, that's what the rest of these are about here. I looked at this just a couple days ago, guys. All right, sexual maturation. So primary sex characteristics, parts of the body directly involved in reproduction, so that would be testicles, ovaries. Secondary sex characteristics are not necessarily those responsible for reproduction. So they're, like the chiseled chest and the square chin and jaw or whatever it is that, you might find attractive about the opposite sex. So the examples they give here are voice changes, breast development, odor, acne. Those aren't necessary for reproduction, but they happen because of the hormones involved and the changes that are happening. So sudden emotions, teenagers are known for not necessarily making the best decisions and basing their decisions off of emotions. All these hormones and these surges and these roller coasters, like you saw in the chart, are all part of this. So social and cultural reactions play a big role. Timing. So we mentioned a little bit that age of onset of puberty depends on a lot. Stress causes it to be earlier, so maybe that's why we have such an early go at it in the U.S. Weight, malnutrition will delay. Genes and ethnicity have a big role. Gender, girls are ahead by about half a year or so. Timing. Do you think it's advantageous to be early maturing? I don't know. What do you guys think? So you can pause the video and consider that if you like. What about boys? Do you think it'd be good for them to mature early? I personally think it'd be better for them to be closer to the 12 and a half. I kind of hinted at that already. It'd be hard to explain menarche to a 9-year-old girl or even earlier. So early maturing girls are at a higher risk of teasing, early sexual activity because you got those hormones floating around, eating disorders, and early substance abuse. And this comes from the Developing Person Through Childhood, some psychology textbook. Early maturing boys are at higher risk of rebellion, breaking the law, stress and depression from relationships. So didn't we just say stress makes it even earlier maturing? So that's kind of a vicious cycle there. Late maturation. So boys might be kind of undervalued for athletics if they are late maturing, and girls might feel a little anxious about when they're going to flower or have their puberty. So bigger and stronger the growth spurt. So you get weight, then you get height, then you get muscles. Females get fat, males gain mostly muscle. The lungs and heart increase in size. Other physical changes, the lymphoids will decrease in size, and that makes you actually less susceptible to asthma and colds. Skin's going to get oilier, sweatier, more acne prone. I'm sure you're all familiar with most of that. Body rhythms. So this is always a fun one here. Most teenagers prefer to stay up late and sleep in late. Been studied that high schools should not have classes starting at 7 o'clock, 7:30, getting you guys busted like 5:30 in the morning. Everything says we should start at 9 and just delay the after school activities into the evening. That's really hard to do and pull off and still have all those after school activities. I think that's I don't know where the slide went, but it's definitely something that we've talked about in classes before, that we should start later, but we just don't. We ignore the research in that case. In general, though, adolescence is one of the healthiest periods of your life. Even if your parents are just doing the best they can and you're getting not so healthy meals, or they think they're serving you healthy stuff and you're not, chances are your body's going to live and adapt and have a great teenage years and early 20s. And the problems won't show up to that until your 30s, 40s, 50s. So it's a healthy period. Problem-free reproduction, easy to get pregnant, peak athletic performance, high energy and endurance, body systems function at an optimal level. It's probably why people say, high school might be the best time of your life. I don't think so. I think, I always joke that the day I peak will be the day I die, because things just keep getting better. So death by disease is extremely rare. The most common cause of death is just accidents, because you're making those emotional, kind of not well thought out decisions. So health during adolescence, unfortunately, teens seem to engage in risky behaviors. Increased risk of eating disorders, fatal accidents, suicides, homicides are leading cause of death. So we just talked about that. And there's lots of help out for that. Please talk to your school counselors if you're considering any of these things. If you're just feeling down, just go. All kinds of resources available. Twisted Memorial, I mean, they did this when I was in high school. They put out like a really wrecked car. Just be careful out there. It's not worth you getting hurt, and it's not worth hurting somebody else. Accidental deaths during adolescence are due to body changes like testosterone. Oh, my friends are doing 125, I can do the same thing. Don't do it. Just play safe. Brain changes the limbic system. You learned in freshman leadership that limbic system's that emotional system. That's the one that doesn't really fully develop until you're 25. So you're not going to make sound, non-emotional decisions until you're fully brain developed at 25. So just keep that in mind. Am I being a little emotional about this? Social context like alienation or being macho can lead to that. So how many teens do you think have had sexual intercourse by age 14, age 17? The answer might surprise you. So about a quarter have had sex by 14, 50% by 17, and 90% by 21. And again, this is a different statistic than the one we started with a little earlier. This one came from a psychology textbook. So cultural influences influence how sexually active a teen might be. So it could vary even by probably U.S. state. Pregnancy has a huge physical toll on the body, and it can be pretty problematic for anyone who's under 15. It can interfere with hormones, weight, nutrition. It really does tax the body. I mean, I joke that it's this little parasite that's like sucking nutrients from the mother. You can just think, if you are still going through that chart and developing through puberty, and then you get pregnant, and your body's going to do everything it can to support that DNA, that next generation. So it's going to give everything it's got to the baby instead of to your developing body. So you're going to be stunted in some ways. Maybe you won't be recordably shorter, but who knows? We wouldn't have been able to measure you before or without the pregnancy. All right, so it's not recording twice. So third time here on this slide, everything else is doing great. So sexually transmitted infections. 50% of teens will have one during their adolescence, which is a very high number. I think it's only beaten out by the elderly populations in homes. They have the highest rate of infection of STDs. Now, obviously, you don't want one of the viral ones like HIV and syphilis, but chlamydia is extremely common and can be cured with antibiotics, but we don't want to do that all the time because they can become resistant. So you can get this thing called pelvic inflammatory disease, where essentially you're living with like chronic chlamydia or gonorrhea, and it can cause infertility later in life. It can be permanent, so you'll never be able to get pregnant. And I know for a lot of teenagers, baby's not in the forefront of your mind, and it really shouldn't be. But your hormones are still changing, and that might be a very different opinion in 5 or even 10 years. So don't take that chance away at the moment. So yeah, I hope you guys enjoyed this. I'm getting a little more comfortable with just sitting in my garage giving a lecture. Feel free to contact me in any way that I've given you. I don't want to say this because it's posted online, but you've got my contact info if you have questions. Happy to help you. And have a great couple of weeks.